Myself, Dr. Shanti Kumar Bardhan, Professor, Department of Mechanical Engineering, JIS College of Engineering, Kolani. My subject topics: Advanced Welding Technology, ME 703A. Today is the 29th lecture. Welding defects. So one of the important chapter is welding defects. When you do some welding, there may be some defects. So what are the defects we will discuss today in this class? Types of defects: slack inclusions, undercut, porosity, incomplete fusion, overlap, underfill, spatter, excessive convexity, excessive weld reinforcement, incomplete penetration, excessive penetration. Slack inclusions. Number 1 point. Slack during the welding, slag may be some slag is there. It will be, since slag is very lighter weight, so it will come about the top of the surface. But maybe some slag may be included in the inner depth of the welding. The causes: low amperage, improper technique, slow travel rate. To prevention to this, increase amperage so that it will melt properly. Increase travel rate so that slag will be in the top of the surface. Repair, if included slag inclusion is there. Repair, how to repair? Remove by grinding or other mechanical process, and also maybe by gouging, carbon electrode gouging. So it will remove the slag and then fill up with a normal welding. This is this welding, the slag is included, so it is a difference. Undercut cause: high amperage, wrong electrode angle, long arc length, rust. Undercut, this is undercut. This point is undercut, and maybe this point. This is somewhere. This is undercut. This is undercut. So causes: high amperage, wrong electrode angle, long arc length, and rust. Prevention: set machine on scrap metal to collect parameters. Clean metal before welding. Repair: weld with smaller electrode. Sometimes must be low hydrogen with preheat. So low hydrogen electrode with preheat. So there should not be any moisture in the electrode. This is the undercut. This portion is this. This is called undercut. This is called, it's not a weld properly. This is undercut. Porosity. Porosity means this is the porosity. These are the porosity. This is the porosity, and this is also pores. Porosity means some pinholes and porosity. It is a defect due to gaseous hydrogen trapped in the liquid welding metal, and after cooling, during cooling, it cannot escape. So porosity may occur. Incomplete fusion cause: low amperage, steep electrode angle, fast travel speed. So fusion is not completed. Fast travel speed, short arc gap, lack of preheat, electrode too small, unclean base metal, arc of seam. So these are the causes. So many causes: low amperage, steep electrode angle, fast travel speed, short arc gap, lack of preheat, electrode too small, unclean base metal, arc of seam. Prevention: eliminate the potential cause. Repair, remove and rebuild, being careful to complete remove the defective area. Remove and rebuild, being careful to complete remove the defective area. So this is the incomplete fusion. This is including this gap. There is a gap during this angle, welding in the angle, and this is also this incomplete fusion. This portion is a incomplete fusion. Overlap. This is overlap. This is up. It should be up to this point, but it is overlap. So, cause improper welding technique, steep electrode angle, fast travel speed. So, fast travel speed causes. So, control is not there. So, it was due to fast travel speed. This is overlap. This is overlap. This is not. Bead is not correct. This bead is correct, but this is not bead is not correct. So, some overlapping is there. Prevention overlap is a contour problem. Proper welding technique will prevent this problem. So welding technique must be improved so that overlap can be, and so skilled labor is required so that it should not be overlap. Parameters should be checked, parameters should be controlled, parameters should be set so that overlap should not be there. Underfill. This is underfill. This is underfill. It's not fill up, properly fill up. Improper welding technique. Even say apply proper welding technique for the weld type and position. Use deeper bead before the cover pass. Repair simply weld to fill. May require preparation by grinding. So before welding, grinding is required so that it should be, and also after grind, this is may require preparation by grinding. So before welding, preparation is required so that welding should be correct technique should be applied, correct welding technique should be applied, and weld type and position also. Spatter. This is weld spatter. Just see the small particles. These are the particles. Spatter. This is because due to some so many causes of high arc power, magnetic arc low, damp electrode, and also the damp due to damp electrode, this is may occur and the diameter of the electrode also cover flux covered in the electrode type of fluxes that is also depends to this spatter causes of pattern. So high arc power, so it is melted and it can spatter is there. Magnetic arc blow, damp electrode. If it is a damp electrode, the moisture is there. Due to some moisture, there is some spatter may occurs. Prevention: reduce arc power, reduce arc length. Arc length should be reduced. Use dry electrode. Repair: remove by mechanical process. This should be grinded enough. This is a welded spatter, and this is weld surfaces, steel surfaces. Excessive convexity. Amperage causes amperage and travel speed. This is a convexity, excessive convexity. Arc length is this, length is this, so it is okay. But this is a throat and this is overlap, cover. This is a excess material is there. So amperage causes excess convexity and excess material. So amperage and travel is the causes. So it should be faster travel speed. Slow travel speed, so it is excess material is there. Prevention, observe proper parameters and techniques. Is it correct? Observe proper parameters and technique. Repair must blend smoothly into the base metal. So should be welded root and also the correct way technique should be taken so that proper welding can be done. Excessive concavity. This is concavity. This is the concavity. This is the should be, and this is concavity. And this is concavity. Just see this figure causes amperage and cable space. This is because of that excessive concavity. Amperage should be controlled, and tablet speed also should be controlled. The main causes of the welding defects are the basically because of the amperage, correct ampere, and tablet speed. These are the main thing, and also the electrodes, welding material. These are the effect. These are the causes for this excessive concavity or any other defects. Prevention: observe proper parameters and techniques. Repair: it must blend smoothly into the base metal. Excessive weld reinforcement. This is uh, this is excessive. These are the thing. It is welded more than that. That means extra amperage was there, so melt. It was melt with over it. Face reinforcement, face weld. Travel speed too slow, amperage too low. Prevention: set travel speed and amperage on scrap plate. Repair: remove excessive reinforcement and feather their weld to a smooth transition to the base metal. This is a excessive weld reinforcement. Let's see. And also this is the angle is reinforcement, so that it is depth was increased. Weld face reinforcement. This is face reinforcement. Incomplete penetration. So penetration is very, very important for any welding joints, mostly part joints and other absent also. Causes low amperage, low preheat, tight groove opening, fast travel speed, or short arc length. This is short arc length. And prevention: correct the contributing factors. Correct the contributing factors. Prevention. So these are what are the factors of current, preheat of the material, tight root opening. Root opening should be correct so that some gap must be there. Fast travel speed, arc, short arc length. Prevention is correct the contributing factors. Repair back gouge and back weld. So reverse the workpiece and the back weld can be done, or it has to be removed. Back gouge and back weld. We have to reverse this and the gouging, and then welding is done. Incomplete. This is incomplete root. So there is a gap in the root. So penetration is not proper done. Excessive penetration. This is excessive penetration. This is the excessive penetration. Penetration with this and excess penetration. This is excess penetration. This portion. And this is done. This is welding excess penetration. So excess penetration also causes more heat affected zone, causes material detrimental for that. So excess penetration also not required. Poor penetration is not required, excessive penetration also not required. Crack caused by thermal stresses. This is the crack caused by thermal stresses. This is the due to thermal stresses. This is a crack in the surface. This is also crack. So longitudinal crack. This is also crack. This is crack. So this is the weld material, and this is the base material. Crater crack. This is called crater crack. This is called crater crack. In this figure, there is a crack in butt and T joint. This is T joint. This is butt joint. The toe crack. This portion is called toe crack, weld, and this is longitudinal crack, and this is underbit. This is underbit crack. This is base material. This is the transverse crack. This is transverse crack. This is base material. So there are several cracks at the crater crack is mainly this caused by thermal stresses. This type of cracks welded joint cause thermal stresses that develop during solidification and contraction of the weld bit and welded structure. Magnetic blow. Why? Magnetic field causes the arc to deviate from its intended course. Intended course. What to do? Use steel block to alter magnetic path around arc. Divide the ground into parts. Weld in some directions. Arc blow. Use a short arc. Locate the ground properly on the work. Use AC welding. Weld stresses. Any welding, there must be stresses due to heat. Why faulty welding and faulty sequence, rigid joints? This is faulty welding, welds, faulty sequence, and rigid joints. What to do? Allow parts to move freely as long as practical. Make a few pass as possible. Pin deposits. Anneal according to thickness of weld. Move parts slightly in welding to reduce stresses. Wrapping. Why? Shrinkage of weld metal, faulty clamping of parts, faulty preparation, overheating at joints. So these are the causes of wrapping. What to do? Pin joint edge before welding. Weld rapidly. Avoid excessive space between parts. Clamp parts properly. Back up to tools. Adopt a welding procedure. And so fixture must be correctly fitted. Welding fixture must be required. Welding fixture must be correct so that there is no wrap, there is no sinkage. Sinkage also very important of metal. That we have to consider. Slow heating, slow heating, slow cooling is very important. weld rapidly or uniformly. This is the causes of wrapping. Distortion. Distortion is another problem in the welding defects. Uneven heat, if you give uneven heat, then maybe distortion is there due to uh, expansion and contraction, proper sequence, deposited metal sink. This is distortion is there. Then what to do? Tap or clamp parts properly. The fixture must be correctly fitted. Tap or clamp parts properly. Form parts before welding. Dispose of rolling or forming chains before welding. Distribute welding to prevent uneven heating. Examine structure and develop a sequence. So distortion is there. So these are the defects. Brittle welds. This due to wrong electrode, faulty preheating, metal hardened by air. These are the causes, right? Wrong electrode, wrong selection of electrode, and wrong selection of electrode also material selection. Material to be welded, that has to be taken care so that electrode should be in that respect. Faulty preheating, metal hardened by air, these are the causes. What to do? Preheat at 135 to 260 degree if welding on medium carbon steel or certain alloy steel. So 200, 250 degrees centigrade is okay, and make multiple layer. When you do welding, say for 5 millimeter thickness or 6 millimeter thickness welding to be done. So pass one for good joining, and then second, third, multi-layer weld. That will make the stick brittle weld. Anneal after welding. It should be heat treated. Anneal after welding. After welding, it should be annealed. Use stainless or low hydrogen electrode for increasing weld ductility. This use stainless steel or low hydrogen electrodes for increasing weld ductility. That has to be taken care for proper use of the welding. Thank you. This is the end of this.